So in this question, we have a graph. We'll do our Oizerga analysis. So tracking along the x-axis, we see it does go to 0. And along the vertical axis, it goes to 0. So we are situated right in quadrant 1. Our y-axis is force with normal units. X-axis is time with normal units. So therefore, any questions about force and time, we'll just simply read off the graph. The gradient, delta F over delta T, is the rate of change in force. And the area is F delta T, which is the definition of impulse. And we also know that delta P is M delta V, and that an impulse brings about a change in momentum. So these two relationships are equal to each other. Well, you can also look up at the graph and see that it appears that there is approximately constant force of about 3 newtons. It's applied over 2 seconds. So, armed with that information, we go to the question. So the student does an experiment where an object travels across a horizontal surface. Let's define this as the positive direction and this is the negative direction. While for 2 seconds a net force is applied that initially travels with a speed of 0.5 seconds. We've got a mass and we've got a speed. We want to be careful because the word speed is given, not the velocity. So we don't know if the object is traveling in this direction or in this direction. But we do know from the graph that the force is positive. So the force is acting in this direction. So if the force is acting in this direction, why the speed will increase. But if it were traveling in the other direction, the speed will decrease. So for 2 seconds, while the net force, it's used to create the graph. If frictional forces are negligible, can the student use the graph and the known data to determine the momentum of the object after the force has been applied? Well, from the graph, we can determine the change in momentum. And we write an expression for the change in momentum, that's P minus P0. And the momentum afterward would be the instantaneous momentum given by P. So P then is delta P plus P0. Now from the area, we can determine delta P. And to know P0, we would need to know mv0. And we know the mass is 2, but we don't know if the velocity is plus 0.5 or minus 0.5. So this is unknown. So the final answer is no, we cannot. Yes is out. The data is too scattered. That is not reasonable. It's perfectly reasonable for us to come up with an approximate average of 3 newtons. Needs to know the direction that the force is applied, because the applied force will be the same direction as the change in momentum of the object. So the change in momentum of the object is positive, but we don't know if the thing is slowing down or speeding up because we don't know what V0 is. So that's why it's choice D.